Dr. Shelley, we also talked another point in the past that is one of the most confusing statistical concept for most people is hypothesis testing.
Mhm.
Actually, for me, that's the second most confusing. So why is hypothesis testing, the concept of hypothesis testing, so hard for people to understand?
Well, it's primarily because the classical approach to testing hypotheses amounts to what you could call proof by contradiction. So you don't directly prove that a parameter has a particular value, which is often what the hypothesis testing is about. What you do instead is to rule out other possible results. So that's like proof by contradiction, if you will.
Yes, yes.
It's really more like, well, proof isn't quite the right word anyway, but that's the way that people tend to think about it. So you're finding what range of values just aren't likely, not impossible, but are not likely. And then once you've ruled that out, then you're back at a point where you say, yeah, okay, there's some other things I can't rule out. But the problem is that's not the same thing as saying I know exactly what the correct value is.
Mm.
And all of that has to do with the fact that if you draw a particular sample out of a larger population and use those results to get some kind of parameter estimate, that's just one result. And you have to be able to generalize beyond just the one case. And so that goes back to probability and also the notion of a standard error, which I think we might get to in a little bit. Well, standard error really is the linchpin behind hypothesis testing, because the numerical value of a standard error basically is how much internal variation is there in this particular sample of data, and then how big is that particular sample. So it's essentially standard deviation, the sort of intrinsic variability within a variable divided by the number of observations, the square root of that actually that you have
Yes.
in the data set. Yeah, and so if you have a bigger data set, you're dividing by the square root of a bigger number, right? And in that event, you have a larger denominator and the standard error gets smaller.
Mm.
So the bigger your sample size is, the smaller the standard
Yes.
error, meaning that you have
Higher certainty.
Yes, exactly. Contrary wise, if you have a small sample, the standard error is a lot bigger. And that's why it's often said it's harder to generalize in smaller samples, just simply because you've got whatever amount of variation. And if it's only based on a little bit of information, you just can't be as sure about the result.
Yes. Dr. Then the question is, we say hypothesis testing, we prove the alternative cannot be right, right? So, and we say, why don't we just prove that is happening, the right thing, just prove the right thing
Well,
instead of prove the alternative thing? How can you convince people that we have to prove the alternative instead of prove what is happening?
well, it comes down to the use of the word prove, actually. So
Yes, we
so
talk
there
about that.
there are proofs, plenty
Uh,
of them in statistics and of course
yes.
math more generally. So some things are absolutely true and you can prove that they are true, like by a little bit of algebra or calculus or sometimes both. It absolutely is true that the long run average of the sample means from a whole bunch of samples, it absolutely is true that in the long run, they average out to the population mean. And so that's a statistical, mathematical proof using expected values. So that's an honest to goodness proof. Using the word prove in the context of testing hypotheses, it just doesn't mean the same thing.
I see.
So part of this is kind of a bit of a language trick in English. I'm not sure about other languages so much, but in English, proof means a couple of things that are almost contradictory. So proof, like what I was saying before about the long run average of all the different sample means is the population mean. That's just absolutely true. And you showed that with a little bit of algebra. So that's proof in the sense of we know that's absolutely and always true.
Mm.
But the word proof also has the meaning that you're testing. You're checking to see if something might be true. And so proving something in the hypothesis testing context, it's kind of like what is often referred to as a proving ground.
Mm.
A place where you might check out a car to see if it can set a new world land speed record. So it literally means you're testing to see if you can achieve a goal or get a particular outcome. And so the use of the word prove or proof in the context of testing hypotheses, it isn't the mathematized, we know for sure this is now and always true kind of proof. It's a matter of checking. So it's just, it's this other use of the word prove or proof. Putting something to the proof means putting it to the test, seeing if it's true. And so that, unfortunately, the same word gets used to imply things that are really very different from each other. So for testing hypotheses, it's best not to use the word prove or proof, unless you know that it's in this context of testing.
Yes.
Because it's always a matter of testing to see what the likely consequence is of a certain amount of data.